Hashfry is the origin of the universe, the Big Bang, by Xuefeng. In the 1920s, when the 100-inch telescope on Mount Wilson observed galaxies moving away from us at increasing speeds, some scientists naturally concluded that the universe originated from the Big Bang. But is this the truth? Can we conclude that these galaxies were initially aggregated and then started to move apart due to an explosion, forming the universe as we see it today, just by observing galaxies moving away from us from Earth's perspective? If we observe from the opposite perspective, we'd see galaxies moving towards us. Should we then conclude that the galaxies in the universe are moving towards each other? It's like a train traveling between stations A and B. If we see it moving away from station A, it is undoubtedly moving towards station B. Consider a globe. If you stand in Oslo, Norway, and imagine people in Cape Town, South Africa, you might think they live upside down, and vice versa. So, who is actually living upside down? Judging everything from a single point of view inevitably leads to different views from different perspectives. So, what is the phenomenon of moving away about? Our Earth and the observable universe are merely tiny particles in the vast cosmos, which is a Taiji ellipsoid. Near the short axis, the distance between celestial bodies expands, while near the long axis, it contracts. In a few billion years, we will observe galaxies moving towards us at increasing speeds. How will we explain this then? When ordinary people make mistakes, it only affects themselves or a small circle around them. However, a small mistake by great figures can lead to confusion, bewilderment, and suffering for generations, especially scientists, who must be cautious and not be like the blind men feeling the elephant and making conclusions based on partial information. Let's hypothesize a Big Bang and analyze its validity. We know that any explosion requires an external force. Without external force, what can cause self-explosion? If it were possible, hydrogen bombs, atomic bombs, intercontinental missiles, and other explosives in weapon arsenals worldwide would have exploded by now. Why haven't they? An egg needs external heat to become a chick. A fertilized egg needs continuous external nutrients to develop in the womb. Earthquakes and volcanic eruptions result from the sun's thermal energy and gravitational forces from other celestial bodies. If the Earth were placed in a location with no external forces, it wouldn't even rotate, let alone have earthquakes or volcanic eruptions. Let's assume the unlikely Big Bang occurred. What are the initial velocity, angular velocity, and linear velocity of the exploded fragments? Are they moving at constant speed, accelerating or decelerating? Are they moving in straight lines, arcs, curves, or randomly? If in straight lines or random directions, how did the solar system and galaxies form? If in arcs or curves, think about the enormous energy required for such an explosion. If the explosion had sufficient energy to cause the fragmentation, the fragments would likely reaggregate due to gravity. An explosion of this magnitude would not result in curved trajectories. Would fragments of varying masses travel at the same speed? If not, how has the Earth remained in the solar system for billions of years? If yes, why does Earth orbit the Sun? A bullet, once fired, follows a curved path due to Earth's gravity and decelerates until it stops. Does the movement of celestial bodies resemble this? Can the Earth's velocity precisely maintain its orbit without flying off tangentially or falling into the Sun? If we assume all celestial bodies were initially a single large sphere and could self-explode without external forces, how did the surrounding void form? How large is this void? Are there other celestial bodies billions of light years away? If so, where did they come from? If not, how could this massive celestial body float in a void without external gravitational forces? If it couldn't, should it have accelerated in a straight line through the void? If so, wouldn't it have burned up like a meteor? If this initial massive celestial body exploded during its movement, how did it start moving? Who pushed it? Where did this massive celestial body come from? Should we still believe in the Big Bang Theory? Conclusion. The Big Bang Theory, which suggests an explosive origin of the universe, faces numerous logical and physical challenges. It assumes the existence of an initial massive celestial body and a void, but fails to explain the origin, movement, and the subsequent stable structures of celestial bodies without external forces. The theory needs more comprehensive and unconventional thinking to address these gaps and present a coherent explanation of the universe's origin and dynamics.